Hello everyone, very good evening. This is Sanjay Rathi. How are you guys? Now today's topic is transient and it is part of concepts with PYQ series from network. And this is important for branch electronics, electrical and instrumentation. And that is the GATE 2025 and 2026 preparation. Okay. Please already I think you have solved the question, guys. Everyone, let me know that. Please tell me. 1 minute. Okay, I think everything is fine now. So guys, this topic is important and we are going to solve some important questions and from basic to up to what advanced level, right? A to Z you will get the idea about transient, right? And in coming session I will arrange session for initial conditions, guys. So चलिए आते हैं. Then that is so again everyone, very good evening. This is Sanjay Rathi and that is a part of what? Concepts with PYQ series network, and that is my introduction. 24 years of teaching experience and these are my ranks in engineering services exam, and I have trained more than 1 lakh students for these competitive exams. अभी कई लोगों ने प्रिपरेशन अभी उनको लग रहा है कि मार्केट में बहुत रिसेशन है, प्रिपरेशन करें या नहीं करें, सो ऑन. तो भाई देखो, आप जितने दिन सोचोगे उतने दिन आपका टाइम आपके हाथ से निकलता जा रहा है. तो आप प्रिपरेशन करते रहिए, साथ में अपनी स्ट्रेटजी भी बनाते रहिए कि आपको आगे क्या करना है. देन गाइस, दिस इज माय टेलीग्राम चैनल. यू कैन ज्वाइन, right, to get the PDF of the session and you will get the notification about the exams. You will get the detail about the courses on our app. Everything will be discussed on what? This channel, that is Electronics by Sanjay Rathi. Link is given in description. Everyone please join that. Like the session and share the link of this session, and most important, subscribe our channel so that you will get the notification. Now, अब आते हैं सीधा मुद्दे पे आ जाते हैं. क्वेश्चंस क्या हैं एंड सो ऑन. पहला देखो, एक पहला क्वेश्चन दिया हुआ है आरएल सर्किट पर, और इसके साथ ही मैं आपको बताने वाला हूं कि आरएल सर्किट काम कैसे करता है, और इंपॉर्टेंट है आरएल एंड आरसी सर्किट, गाइस. तो ये क्वेश्चन आप बनाइए जरा, क्या होगा आंसर. ये दिस इज द क्वेश्चन फ्रॉम ट्रांजिएंट. तो ये है, देखो यहां पर हम लोग क्या जान रहे हैं. देखो, प्रीवियस ईयर क्वेश्चंस के साथ साथ आपका क्विक रिवीजन भी होगा, आपको आइडिया भी लग जाएगा कौन कौन से टॉपिक्स इंपॉर्टेंट हैं. आरएल सर्किट क्या होता है, आरसी सर्किट क्या होता है, एंड हाउ टू फाइंड द इनिशियल कंडीशंस, राइट, एंड हाउ टू फाइंड द इनिशियल वोल्टेजेस अक्रॉस द कैपेसिटर और करंट थ्रू द इंडक्टर व्हेन देयर आर डिपेंडेंट सोर्सेज आल्सो. ओके, तो चलिए अब देखते हैं. ये है क्वेश्चन. For the RL circuit shown in the figure, the input voltage is UT. UT means unit step function. The current IT is. अगर input voltage जो है VIT, अगर वो आपका है UT, UT means हो गया आपका स्टेप सिग्नल है. Then अब बताइए, what is the graph for that? ये आपका हो गया UT. ओके, दिस इज द UT. टाइम here it is 0, suddenly it will become 1. This is the unit step signal. तो ये हमारा VI है. अब आपसे क्या पूछा, सॉरी, आपसे क्या पूछा है, अब आपको बताना है इस क्वेश्चन में कि अगर आरएल सर्किट है तो आपका डायग्राम कौन सा होगा. तो सबसे पहले देखो, करंट अगर निकालना है, यूटी दिया हुआ है, तो इंडक्टर डज नॉट अलाउ सडन चेंज ऑफ करंट. तो व्हाट इज द इनिशियल करंट, बिकॉज इनिशियल वोल्टेज इज 0 फॉर टी लेस देन 0. टी 0 नेगेटिव, दिस सर्किट इज शॉर्ट सर्किटेड, right, and that why, because that voltage is 0. तो एक one by one I am going to solve. This is 0 because there is no voltage. So what is the current here? 0. Initially it is unenergized circuit. Inductor does not allow sudden change of current, and that's why I0 negative is equal to I0 positive is equal to what? 0. So current sudden change होगा नहीं. Now we are going to apply a voltage of 1 volt. When we are going to apply a voltage of 1 volt, this is the 1 volt. Step signal, we can represent like this, 1 volt. This is the diagram valid for t greater than 0. Now, what is the final current? Final current means exactly at infinity. Under steady state, inductor acts as short circuit. So when inductor acts as short circuit, what is the current here? 1 divided by 2, that is what? 0.5. 0.5 ampere. Right? अब देखो यहां पर देखो ये दिस इज द फाइनल करंट इज रिप्रेजेंटेड एज 0.1, तो ये तो आंसर नहीं हो सकता. 0.1, that's why this is not the answer. Here it is a 0.5. Final current is what? 0.5. Final current is 0.5. So A may be the answer or C may be the answer, guys. Now, then we will find what is the time constant of the circuit. What is the time constant of the circuit, guys? Time constant means L by R. L by R, that is 1 by 2. 1 by 2. That is the time constant. Or remember, then finally what is the equation? IT is equal to I final minus I final minus I initial e raised to power minus t by tau. ये आपकी एक इक्वेशन है. ओके, देन what is the final value? We have calculated the final value 1 by 2. This is the final value 0.5. What is the final value? 0.5. Initial value 0. T by tau means 1 by 2. Then its equation will become 0.5 1 minus e raised to power minus 2t. And that is the equation. Exponentially increasing function. Exponentially increasing function. Now, exactly at t equal to 0, you will get from this formula I is equal to 0. Exactly t equal to infinity, I will become what? 0.5, because this term will become 0. But exactly at time constant, what is the time constant? 1 by 2. So exactly at 0.5, when I am putting the t is equal to 1 by 2, e raised to power minus 1. So it will become, this value will become 0.5 1 minus e raised to power minus 1. And what is the value of the e raised to power minus 1? 0.368. So what is the 1 minus 0.368? 0.632. So it will become 0.5 into 0.632 times of that. 0.5 into 0.632 times of that. So half of that. So what is the half of this? 0.3, right? This is the 0.3, then 1, and then 6. 0.316 or nearly equal to what? 0.32. The value is what? 0.32. This is the value of the final value. Now, this is the 1 minus e raised to power minus 1 is 0.632. So, in one time constant, it will reach up to what? 0.316 volt. तो देखिए जरा कौन सा आंसर है? This is the first one, but what is the time constant given here? 2 seconds. But the time constant is not 2 seconds. Time constant is 1 by 2 seconds, and that's why the answer C is the correct one. Final value is 0.5. Exactly at one time constant, it will reach to 0.31. Already we have calculated that. This is nothing but 0.632 times of final value. This one. And finally, it will reach to what? 0.5. तो ये graph है ना ऐसा बनता है. This is the graph. 1 minute. Okay. What is the graph here? like this, exponentially increasing function. Like this. In one time constant, it will reach to 0.632 of final value. Okay, this is the current and that is what time. ये हो गया पूरा किसके बारे में? About what? RL circuit. About RL circuit. Now, this is about the RL circuit. अब आते हैं जरा about what that is the diagram, and that's why now with this question I am giving you the idea. You have to get the command over what? Is it audible? You have to get the command over RL circuit, right? Source free or with source, RC circuit, source and without source. So now next question. Now next question, I think you have got the idea about this. This is a very, very important one, RL circuit. Now second question is on RC circuit, guys. अब देखो यहां पर क्या दिया हुआ है, स्क्वायर इन 2005 it is of 2 marks. A square pulse of 3 volt amplitude is applied to RC circuit shown in the figure. चलिए बताइए जरा आंसर क्या होगा. Read question carefully. And everyone, why please share the link so that the student will join. Just I want to continue this session and I am going to continue next week. I will take what steady state analysis of sinusoidal signal, initial condition. Tomorrow again we have the session on what 2-port network. So please watch my all the previous 2 sessions on what theorems on basics of the network. Then that is the 3rd session on transient. 4th session will be on 2-port network. उसके बाद आएगा स्टडी स्टेट एनालिसिस ऑफ साइनोसॉइडल सिग्नल, इनिशियल कंडीशंस, क्वेश्चंस ऑन इनिशियल कंडीशंस, हाउ टू फाइंड द आई डी आई बाई डी टी, डी वी बाई डी टी. एंड आई विल कंटिन्यू दिस series with what questions from standard textbook so that you will get the idea how to get the command over particular subject. जरा बताइए क्या होगा इसका आंसर. Yes, please. Now, देखो जरा. Square pulse of 3 volt amplitude is applied to a RC circuit shown in the figure. The capacitor is initially uncharged, unenergized capacitor. The output voltage V2, this is the V2, at time t equal to 2 second is. देखो, what is the value at, this is the 3 volt up to 2 second, and exactly at 2 second there is a sudden change. The output input voltage will become 320 in 2 second, right? There is a sudden change. And what is the initial voltage across the capacitor? 0. So there are 2 times there will be a sudden change. At what, at the beginning of the pulse or at the end of the pulse. At the beginning of the pulse it will switch from 0 to 3 volt suddenly, and at the end of the pulse it will switch from 3 to 0 volt suddenly in 2 seconds. Now how we can solve this? Remember guys, capacitor does not allow sudden change of voltage, and we have to calculate the voltage across the resistor, not across the capacitor. So since VC0 negative is equal to VC0 positive is equal to 0, initial voltage across the capacitor is 0, and that's why initially capacitor act as what? Short circuit. Short circuit. So what will be the voltage? Suppose we are applying the 3 volt at this point, exactly at t equal to 0 plus, this is the 3 volt initially. So what will be the output? It is also 3 volt. Output is 3 volt. Right. Now what is the time constant of the circuit? The time constant is the what? 1 kilo ohm, 0.1 microfarad. So you can find the time constant of the circuit. Time constant is RC. So 0.1 kilo ohm 10 to the power 3 into 10 to the power 0.1. 0.1 into 10 to the power minus 6, right? And you will get time constant is equal to 10 to the power 3 into 10 to the power minus 7, 10 to the power minus 4 second. 10 to the power minus 4 second. The time constant is very, very, very low. But tell me guys, what about this line? Batao zara. It is a bigger one or a smaller one? Tell me. If I am saying that the time constant is very, very, very low, how we can say that time constant is very low? Because we can't say what about this line, whether it is a bigger one or a smaller one. We have to compare with something. So when we are comparing with the second line, yes, now we can say first one is the very, very small as compared to second one. Similarly, this time constant 10 to the power minus 4 second is very small as compared to what? Pulse width. As compared to pulse width. What is the pulse width? 2 seconds. This is called pulse width. This is a very important question, guys. The 2 seconds it is given in the question, and the time constant is very, 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 very small as compared to that 2 seconds. So what will happen? When we are giving the 3 volt, no doubt it will take infinite time to charge the capacitor, but we are saying that within 4 or 5 time constant, capacitor will almost charge up to what? 99%. Yes, remember? In a 4 time constant, it will charge up to 98%, or in a 5 constant, more than 99% it will charge. So we can say the time constant, it is what will be, watch this graph. This is a very important diagram, guys. Watch it carefully. This is the pulse. Initially, what will happen? Suddenly, the voltage will rise up to what? Suddenly, the voltage will rise up to this value. Right? 3 volt. Output is, when the inputs increase from 0 to 3 volt, output is also increased from 0 to 3 volt, because we are taking voltage across resistor. Now, what will happen? Capacitor start charging. When capacitor start charging, voltage across the capacitor will increase, voltage across the capacitor will decrease, and voltage across the resistor will decrease. Right? And now, because the time constant is very, very small, capacitor will suddenly charge. When the capacitor charge up to 3 volt, what is the output voltage? 0. Output voltage will become 0 because it is a 3 volt, 3 minus 3, output voltage will become 0. So suddenly the input will rise up to this and suddenly fall like this. Right? Or very quickly it will fall. Very, very quickly. Now, this is 3 volt, this is 3 volt, and output will remain 0 because there is no current in the circuit. No current in the circuit, and that position will maintain up to what? This point. Up to what? 2 seconds. This is the time period of the pulse, tau p. Now, exactly at tau p negative, what is the voltage across the capacitor? 3 volt. So exactly at tau p positive, what about the voltage across the capacitor? It will remain 3 volt. Why? Because capacitor does not allow sudden change of voltage. But what happened to the input? Input becomes 0. Input will become 0. So when the input will become 0, for t tau p plus means 2 plus, after just 2 seconds, input will become 0. Like this is the input. It will switch from 0 to 3 volt. Now it will switch from 3 to 0 volt exactly at 2 seconds. When the input switch from 3 to 0, it will become 0. But what is the voltage across the capacitor? It is 3 volt. So when now we can find the voltage across the resistor. Write down the KVL. So exactly at Tp plus, when I am writing the KVL, input is 0 is equal to plus Vc plus VR. So what is the VR at tau p plus, at 2 plus? It is nothing but Vc minus of Vc tau p plus. And what is the Vc at a tau p plus? It is a 3 volt, and that's why it will become minus 3 volt. That's why the voltage across the resistor or voltage at the output will become minus 3 volt. Right? This is the minus 3 volt. To answer for this question, what is the question here? The capacitor is initially uncharged. The output voltage V2 at a time t equal to 2 seconds is. V2 means output voltage. Output voltage V2 at time t equal to 2 seconds is. So this is the minus 3 volt. Right? What will happen? Suddenly, now graph. At this point, again when the input drops, output also drop up to minus 3 volt. Now, again the time constant is very small. When the time constant is very small, the capacitor will suddenly discharge throughout this resistor. So when the capacitor suddenly discharges through the resistor, so Vc decreases. So when Vc decreases, so what about the Vr? Vr, magnitude of Vr will also decreases. And finally, Vc will become 0. Vr will become 0. So suddenly this will discharge, and that is, we are getting this type of shape. Or this is very important topic, that is called pulse response of RC circuit. Pulse response of high pass RC circuit. आपको पता होना चाहिए. This is the question based on what? Linear wave shaping circuit. Linear wave shaping circuit, guys. And this topic is what? Pulse response. Pulse response of what? High pass RC circuit. High pass RC circuit. Because when there is a capacitor resistor, this circuit is called high pass. Or when there is a resistor and capacitor like this is called low pass RC circuit. It is a low pass filter, it is a high pass filter. So we are dealing with the high pass RC circuit. और ये टॉपिक में अगर आपको कमांड करनी है तो यू कैन रेफर अ बुक, राइट, और अदरवाइज यू कैन फॉलो माय नोट्स. फ्री नोट्स contents are available on my app, that is what Prep Funda. Link is given in description. First of all, join my Telegram channel and then join what app, where go through the PDF section and you can find the notes of analog, where I have completed this topic, linear wave shaping circuit, pulse response of high pass RC circuit. Okay, तो ये आपका देख सकते हो in 2005, it is of 2 mark. Now, so that is the answer, and we are getting the final pulse response like this. We are getting the 2 peaks, one at the input of the pulse and one at the output of the pulse, and that process is called what? Peaking. P-E-A-K-I-N-G, because we are getting the 2 peaks, one at the beginning of the pulse, one at the end of the pulse. And to get the peak, what about the time constant? तो ये है time constant of the circuit should be what? As low as possible. As low as possible. So we have the number of points, guys, on this diagram. For example, when the time constant is 0, then what will happen? We are getting the one impulse at this point and one impulse at this point. So we are converting the square pulse into what? Impulse pulse, and that is called what? Differentiation. Means circuit behaves like differentiator when the time constant is very small as compared to time period of the pulse. राइट, तो ये आपके बहुत से कॉन्सेप्ट है, बहुत ही अच्छा क्वेश्चन था ये. देन आते हैं नेक्स्ट वन. होप आपको समझ में आ गया होगा. प्लीज वॉच इट केयरफुली. आई विल अपलोड द पीडीएफ ऑफ दिस सेशन ऑन माय व्हाट ऐप, फ्री ऐप, यू कैन डाउनलोड देयर. नाउ अब आते जरा, ये देखो कोई कुछ मुझसे डिटेल पूछ रहे थे, तो आप जब ऐप पर जाएंगे ना तो आपको एक कोर्स भी दिखाई देगा, दैट इज व्हाट? काउंटडाउन कोर्स. और दिस इज अ क्रैश कोर्स, स्पेशल 5 सब्जेक्ट फॉर इलेक्ट्रॉनिक्स स्टूडेंट एंड इलेक्ट्रिकल स्टूडेंट्स. व्हाई स्पेशल? बिकॉज आई एम गोइंग टू टेक ऑल द सब्जेक्ट्स, राइट, एंड यू हैव आइडिया अबाउट माई प्रोफाइल. I am having the 24 years of teaching experience. That's why I am going to deal all these subjects for electrical and all these subjects for electronics students. Second thing, I am going to solve questions from what? Previous year questions, the paper, and what then I am going to solve questions from standard textbooks. Okay, for example, in network we will solve questions from Sadiku and Van Valkenburg. In analog we will solve questions from Sadra and Smith and what Millman Halkias. In EDC, we will solve some questions from what is treatment Banerjee and what Niemann and so on. So I'm going to solve some questions from standard textbook from control, Nagrath and Gopal, right? And digital, we will solve some questions from Maurice Mano, RP Jain and so on. So ये है, and you can avail, that is the last date, na? Today it is the last date, 12th of September. Code is what? SRIG Sri Ganesh 10. You will get extra 10% discount. Already we have given the 10% discount on our courses. So this is just for your information. For more detail, you can message me or you can call me at this number 9899940096. तो आपकी डेमो लेक्चर्स आज भी अवेलेबल है. यू कैन वॉच दैट डेमो लेक्चर्स राइट ऑन अवर ऐप. देन अब आते हैं नेक्स्ट क्वेश्चन. 2 millihenry inductor with some initial current can be represented as shown below, where S is the Laplace transform variable. The value of the initial current is. बताओ जरा भाई. Value of the initial current is. बोलो बोलो जरा, सोचो जरा क्या हो सकता है. That current source is converted into a voltage source. Current source is converted into a voltage source, and that is 0.002. It is given. चलो अभी एक थ्योरी आती है, मैं उसको एक्सप्लेन करता हूं. राइट, देखिए जरा. फर्स्ट ऑफ ऑल कोई इंडक्टर है. ओके, जैसे ये इंडक्टर, if we have some initial current across the inductor, let this is the voltage VT or this is the IT. Okay, then we can write what is the V across the inductor. It is given by L di by dt. L di by dt. This is the voltage across the inductor. Now you can find the Laplace of this. So Laplace of this will become Vs. L is common. It will become SIs minus what? I0 negative. I0 means what? This is the initial value, initial condition, right? Initial condition. Now this is what? Vs. Vs is equal to SLIs minus what? LI0 positive. That is the representation. Now we can convert, this is a time domain representation, we can convert it into what? Frequency domain. How we can convert it into the frequency domain representation? Now inductor, same thing. Now watch it carefully. Voltage is divided in series. What? This is the Vs. This is the Vs. Now we have, this is the Is. It is converted into Is. SL. SL means what is the impedance because of the inductor? SL. When Is is multiplied with the SL, there is a drop SL. And now it is a voltage source. It is a voltage source with, this is minus, this is plus because there is a negative sign, and this is Li0 positive. Li0 positive, and that is the representation under frequency domain. Now what is given in the question? SL, this is the Vs. So SL is 0.002S. So what is the value of the inductance? 0.002, because SL 0.002S. So what is the L is equal to 0.002 Henry. Now what is this? 1 millivolt, and 1 millivolt is equivalent to what? Li0 plus. देखो polarity minus plus, this is also minus plus, this is minus plus, and that's why we can say Li0 plus is equal to 1 millivolt. 1 millivolt means what? 0.001 volt. What is the I0 plus? I0 plus will become 0.001 upon L, 0.001 upon 0.002. That is nothing but 1 by 2 ampere. Because the value of the inductance is what? 0.002. So yes, that is what is the answer? 0.5. A. 0.5. That is the A option hai. So this is the representation of inductor under frequency domain. This diagram is given, and that's why we can compare. Right? यहाँ भी बना देता हूँ मैं. This is the given. This is given as 0.002S, and this is given as 1 millivolt. Now you can compare and you will get the idea. From this you will get the value of the L. From this you can get the value of the initial current, and that initial current is asked in this question. ये भी आते हैं बच्चे लोग, कई लोग गेट क्वालिफाई नहीं कर पा रहे because the basic concept is what? Very weak, and that's why I am taking from very basic to what? Up to advanced level. So please get the command over this type of topics. Okay. Or already the value of the inductor is given, otherwise you can find the value from this diagram itself. If suppose nothing is given, again represented as shown, where S is the Laplace operator and the value of the initial current is. It is only of 1 mark question. Then here you go. Next question. In the following circuit, the switch S is closed at t equal to 0. The rate of change of current is given by. भाई देखो, जो भी अटेंड कर रहा है, आप आंसर अगर आपसे बन रहा है तो प्लीज ट्राई टू गिव मी द आंसर इन कमेंट बॉक्स, एंड इफ यू हैव एनी क्वेरीज, इफ यू वांट टू गिव एनी सजेशन, yes, then again you can give the comments or suggestion on comments box on my telegram channel and so on. Okay, then in the following circuit, the switch S is closed at t equal to 0. The rate of change of current is given by. This time the rate of change of current is required, means what is the rate of change of current? di by dt it is required. और switch कब close हो रहा है? Exactly at t equal to 0. To watch it carefully, guys, before t, that is the for t less than 0, what about the switch? Switch is open. When the switch open, what is the current through the inductor? 0. And that's why I0 negative is 0. I0 negative means initial current through the inductor is 0. An inductor does not allow sudden change of current. So I0 negative is equal to 0 is equal to what? I0 positive. Inductor does not allow sudden change of current. Now exactly at t equal to 0, you are going to close the switch. According to the question, it is given the switch is closed at t equal to 0. Now this current source is connected to this battery. So we can convert this current source into what? Voltage source. Is is constant, DC source Rs. So you can convert this voltage source into what? Current source. Right, then it is a, because this is the arrow, this will become plus minus Is Rs. This is the voltage source. Rs in series. This is the R and this is L. This is Rs. Right. Now this is the circuit for t greater than 0. Now what is asked here? The rate of change of the current is given by. Now guys, what is the voltage across the inductor? Voltage across the inductor VL is given by L di by dt. L di by dt. Right. So what is the rate of change exactly at di by dt 0 plus, because it is asked at t equal to 0 the rate of change of the conductor is given by, so this is the di by dt 0 plus is equal to VL by L. VL by L. Now remember, inductor does not allow sudden change of current, but it allows the sudden change of voltage. So what is the initial voltage across the inductor? How you can find? Yes, you can find this is the total voltage. What is the current here? Is, or according to current division rule you can find, right? Then no, current is not Is. So you can find the voltage across the inductor and put here, and you will get the di by dt 0 plus. चलो बताओ जरा क्या है आंसर. ये देखो 4 ऑप्शन है यहाँ पर. IS RS by L, RS RS IS by L and so on. देखो कई लोग 0 बोल देंगे कि because inductor does not allow sudden change of voltage or sudden change of current, but 0 is not the answer, infinity is not the answer. So out of B or C we have the answer. Or you can apply the KVL, guys. You can apply what? KVL. Okay. अप्लाओ KVL. बताइए जरा आंसर क्या है. देखो यहां से KVL लगाओगे ना, माइनस ISRS, दिस इज कांस्टेंट, दिस इज I, दिस इज द करंट थ्रू द सर्किट. Or you can write like this, I small, so that there will be no confusion. I RS plus R plus L di by dt, that is the rate of change of current. So exactly at 0 plus is equal to 0. Exactly at 0 plus, what is the value of the I? 0. Because initially it is unenergized, so already we have calculated initial current is what? 0. And that's why this term will become 0. This term will become 0 exactly at t equal to 0 plus. Now what is the di by dt 0 plus? Di by dt 0 plus will become right side ISRS upon what? L. ISRS upon L. ISRS upon L. B. B is the answer for this question. तो हमने क्या किया? फर्स्ट ऑफ ऑल वी हैव कन्वर्टेड द करंट सोर्स इनटू व्हाट? वोल्टेज सोर्स. एंड देन वी हैव अप्लाइड व्हाट? KVL. एंड रिमेंबर इनिशियली द इंडक्टर विल नॉट अलाउ द सडन चेंज ऑफ व्हाट? करंट. अब देखो कोई बोलता है कन्वर्ट करने, क्या बिना कन्वर्ट किए नहीं हो सकता था क्या? यस, इट इज पॉसिबल विदाउट कन्वर्जन. देखो और ज्यादा इजी हो सकता था भाई. चलिए देखते हैं. इफ सपोज यू आर नॉट गोइंग टू कन्वर्ट इट इनटू व्हाट? वोल्टेज सोर्स. Suppose we don't want to convert it into what? Voltage source. Then watch this. This is the current source. Exactly at t equal to 0 the switch is closed. This is the diagram exactly at 0 plus. What is the current through the inductor? 0. Why? Because inductor does not allow sudden change of current, and that's why this current is 0. This IT through R is what? 0. Initially it is 0. Now inductor has some voltage VL. Now what about this current? Because in this branch the current should remain 0 because inductor does not allow sudden change. That's why this current will pass through this. IS will pass through RS. It will develop a voltage V. What is the V? IS RS. And that is equal to what? VL. Why VL? Because there is no drop. So these are two are in parallel. There is no drop across the R. And what is the VL? So VL will become ISRS. What is the VL? L di by dt. ISRS. And that's why what is the di by dt 0 plus? ISRS upon L. We are getting the same answer. We are getting the same answer. ISRS upon L. We are getting the same answer, guys. तो इसीलिए आपको कोई जरूरी नहीं है कन्वर्ट करना, आप सीधा भी निकाल सकते हो. यह इसका बनाने का तरीका. ओके देन नेक्स्ट आ जाते हैं। ये देखो, ये आपका कन्वर्जन से बन गया, ये विदाउट कन्वर्जन। ऐसे ही हर क्वेश्चन में आप 2-2 3-3 मेथड लगा सकते हो। आई थिंक इट इज विजिबल टू यू, अदरवाइज आई विल राइट द क्वेश्चन। रीड करो, अगला क्वेश्चन है 2014 का क्वेश्चन है, 2 मार्क्स का क्वेश्चन है भाई, सेट 2 मार्क्स क्वेश्चन 2014। In the figure shown, the capacitor is initially uncharged. Again, capacitor uncharged means capacitor does not allow sudden change of voltage. Which one of the following expression describe the current IT in milliampere for t greater than 0? This is I. This is I. We have to find the equation for I. So VC0 negative is equal to VC0 positive is equal to what? 0. Initially, capacitor is uncharged. So first, capacitor does not allow sudden change of voltage, but this time we are not going to find the voltage across the capacitor. We have to find the current through the R2. Current through the, there is the R1, R2 and C, and this is the 5 volt battery is connected, and there are number of equations are there. I think it is visible to you, otherwise I can zoom. 1 minute. Yes. These are the options. Okay, these are the options, guys. You can take a screenshot of that. 5 by 3 1 minus e raised to power minus t by tau, where t is the time constant, is 2 by 3 millisecond, 3 millisecond, 2 by 3 millisecond. हम लोग सॉल्व करेंगे इस क्वेश्चन को डायरेक्टली। देखो, इफ यू वांट टू फाइंड द आई, तो यू कैन फाइंड बाय यूजिंग दिस फॉर्मूला। आई इज इक्वल टू आई फाइनल माइनस आई फाइनल minus I initial e raised to power minus t by tau. Now one by one we will find what is the initial current 0. Why? Exactly at t equal to 0, what is the voltage across the capacitor? 0. Therefore initially capacitor act as short circuit. When the initially capacitor act as short circuit, so what is the current through this? Initially capacitor act as short circuit, and therefore there is no current through this 2 kilo ohm resistor I, and complete current will pass like this, right? This I1 will become R, and this is R1, and that is the 5 volt. Or you can find the current through the capacitor also. IC0 plus, it is given by 5 minus 0. This is the 5 minus 0, this is 0 because it is connected to ground, upon R1. What is R1? 1 kilo ohm. It will become 5 milliampere. But this is the current through the capacitor. And what is the current through the resistor R2? 0. 0. This is the initial current. Now, finally, the capacitor will act as what? Open circuit. When finally the capacitor acts as open circuit, then what will happen? This will act as open circuit. Then the complete current will pass through this. Then it will become I final is equal to what? 5 by R1 plus R2, that is 1 plus 2, that is 3. 5 by 3 milliampere, because resistor it is in kilo ohm. Current will be in milliampere. This is the final current. Now most important thing, how to find the time constant. Because to use this equation, this is the I current through the R, initial current, final current, then what is the time constant of the circuit? So guys, time constant means, for example, if you want to find the time constant of this circuit, then it will become RTH into C. What is the RTH? First of all, what is the value of the C? 1 microfarad, and you have to find the Thevenins across A and B. To find the Thevenins across A and B, remove the C and make the 5 volt battery 0. Remove the C and make the 5 volt battery 0. You will get this type of diagram. 5 volt battery 0. This is R1. This is R2. And that is the A and B. And this is the RTH. Remove the C and you will get the RTH. So what is the RTH? R1 parallel with R2. R1 parallel with R2, that is nothing but 1 into 2 upon 1 plus 2, 2 by 3 kilo ohm. And what is the value of the capacitor? 1 microfarad. Therefore, what is the time constant? 2 by 3 into 10 raised to power minus 3 plus 3, because it is in kilo ohm, and 1 microfarad 10 to the power minus 6, and that's why it will become 2 by 3 milliseconds. 2 by 3 into 10 raised to power minus 3, that is the 2 by 3 milliseconds, because this answer is, it is in second. You can write 2 by 3 millisecond. So out of these 4 options, A and B are correct. This is A and B, out of A and B, one is correct, but C and D are definitely wrong, because the time constant is given as 3 millisecond and we are getting the 2 by 3 millisecond. Then how we can get the current? That is the current. What is the final current? 5 by 3. What is the final current? 5 by 3. What is the initial current? 0. E raised to power minus t by t. That is the tau is the t here. So it will become 5 by 3, 1 minus e raised to power minus t by t. 5 by 3. So 5 by 3, in which answer we have the 5 by 3? In first option we have the 5 by 3. And that's why answer A is the correct one, not B. And the time constant is 2 by 3 milliseconds, guys. तो ऐसे बनाना था, ये देखो ये ऑप्शन. तो कई लोगों को डाउट है, सर क्या ये इक्वेशन हर जगह यूज कर सकते हैं? यस, अभी देखो मैंने आपके सामने यूज किया ना. आई हैव यूज दिस इक्वेशन टू फाइंड द करंट थ्रू R2. यू कैन ऑल्सो यूज दिस इक्वेशन टू फाइंड द करंट थ्रू R1 और करंट थ्रू IC, बट यू हैव टू फाइंड द वैल्यू ऑफ व्हाट? फाइनल वैल्यू, इनिशियल वैल्यू एंड टाइम कांस्टेंट. देन वी कैन यूज दिस. ओके, देन अब आते हैं जरा नेक्स्ट क्वेश्चन जो है. That is in 2016 1 mark question. Switch has been in a position 1 for long time. This is the 1 for long time. Long time means circuit will reach to what? Steady state and abruptly changes to position 2 at t equal to 0. t equal to 0 पे ये 2 पर आ जाएगा. तो long time के लिए अगर आपने यहां रखा है तो क्या होगा जरा? Circuit under steady state means first of all you have to find the initial current, and what is given? If the time t is in seconds, the capacitor voltage Vc for t greater than 0 is given by capacitor voltage. What is the you have to find the equation for Vc, voltage across the capacitor, that is the time. Okay, no problem. Now this switch is closed at, it is connected to 1, and finally at t equal to 0 negative, circuit is under steady state and that capacitor will act as open circuit. This capacitor will act as open circuit. This is the 3, this is the 2, and this is the 10 volt. So what is the initial voltage across the capacitor? Will become 2 divided by 3 plus 2 into 10. It is a 4 volt. And this is equal to Vc 0 plus. Why? Because capacitor does not allow sudden change of voltage. Then अब आते हैं, ये आ गया 4 volt. Now this switch is connected at 2.2 and you have to find the equation. So you have to find the steady state value as well as time constant. Now this is connected here. So you can remove this part. You can remove this part. This part is not required now because it is not disconnected from this part. Now here it is connected. Then okay, what about this 2 ampere 2 ohm current source? Nothing, because it is connected with the current source. So you can remove this 2 ohm. Now exactly at t equal to infinity, this capacitor will act as what? Open circuit. When the capacitor will act as open circuit, this is the capacitor open circuit. This 5 ampere current will pass through this 2 ohm resistor. So what is the voltage across the capacitor? Because there is no drop across the 4 ohm at t equal to infinity. Under steady state, capacitor acts as open circuit for DC transient. So 5 into 2, 10. At infinity it will become 10 volt. 5 into 2, that will become 10 volt. Now we have the initial value 4 volt. We have the final value 10 volt. What is the time constant? That is the most important one. Time constant, guys. So you can find the time constant by RC equal. अभी बताया ना R C. Now first of all C and find the Thevenins. So to find the Thevenins across C, current source will act as what? Open circuit. When the current source will act as open circuit, this is the 4 ohm, this is the 2 ohm, this is 2, and current source will act as open circuit, and here the capacitor act as open circuit AB. Here you have to find the RTH across the capacitor. Across the capacitor you have to find the RTH. This is the A terminal and this is the B terminal. So no need to consider this 2 ohm. Consider this and that. 4 plus 2, 6. 6 ohm is the RTH. What will be the time constant? RTH into C. Where is the C? 0.1 farad. .6 second. So देखिए, we have the time constant, we have the final value, we have the initial value. Means you can find the equation. What is the final value? 10 volt. What is the initial value? 4 volt. And what is the equation, guys? Vc is equal to V final minus V final minus V initial e raised to power minus t by tau. What is the final value? 10. What is the final value? 10. What is the initial value? 4. What is the time constant? 0.6. So it will become 10 minus 6 minus t upon 0.6. तो ये मुझे लगता है डी ऑप्शन मैच हो रहा है. प्लीज चेक. यस, 10 minus 6 e raised to power minus t by 0.6 volt. So try to avoid the silly mistake. Otherwise, if you have the command over the concept, then easily you can solve question on what transient. So everyone please like the session and share the link of this session, and most important, download app from the description so that you will get the PDF, notes, content and start your preparation now. अब ज़्यादा चिंता मत करो, आपके हाथ में अभी ये है कि आप इलेक्ट्रिकल इलेक्ट्रॉनिक्स अगर ब्रांच से हैं तो आप अपनी प्रिपरेशन कीजिए और एक अच्छे इंस्टीट्यूट में पहुंचिए अगर आप हायर स्टडीज करना चाहते हैं, एंड देन अपने प्रिपरेशन कंटिन्यू कीजिए और साथ में स्किल डेवलपमेंट प्रोग्राम में पार्टिसिपेट करते रहिए. राइट, तो मार्केट में बहुत सारे चैलेंजेस आएंगे तो उसके लिए ज़रूरी है. ओके देन, अब आ जाओ. ये that is the last question. Assume that the circuit in the figure has reached the steady state before the time t equal to 0, when the 3 ohm resistor suddenly burns out. 3 ohm resistor suddenly burns out and resulting in open circuit. The current IT in ampere at 0 positive is. In 2016 2 mark question set 3. It is assignment for you. I am going to arrange one session where I will solve all the assignment, guys. So try to solve all the assignment question. In Thevenin's theorem I have given, in basics I have given, transient. Tomorrow at the same time 4 PM I am going to take what 2-port network. Try to solve those questions at 4 PM. Okay, तो आज के लिए इतना ही. So that is, I have started my course on my channel, guys. So you can get the idea about countdown course. That is a crash course, special 5 for electrical, special 5 for electronics. Try to attend live classes, but live as well as recorded, both are available. PDF with annotation available, and you can ask your doubts. I will give the answer for all your questions, guys. For more detail, you can message me at this number, and that is the code SRIG10 for extra 10% discount. You can join now. तो थैंक यू फॉर अटेंडिंग द सेशन. अब क्या करना है आपको, बहुत सारे क्वेश्चंस बनाने हैं फ्रॉम स्टैंडर्ड टेक्स्ट बुक और प्रीवियस ईयर क्वेश्चन. अगर अभी आपके पास टाइम लिमिटेड है, मतलब प्रिपेयर कर रहे हो 2025 के लिए, तब तो आप नोट्स पढ़ लीजिए और प्रीवियस ईयर क्वेश्चंस बना लीजिए. और अगर आप 2026 के लिए प्रिपरेशन कर रहे हैं देन यू कैन सॉल्व क्वेश्चंस फ्रॉम व्हाट स्टैंडर्ड टेक्स्ट बुक। ओके, तो अगर आप इंटरेस्टेड है तो मुझे बताइए, तब मैं आपको बताऊंगा कौन कौन सा इंपॉर्टेंट क्वेश्चन है, क्योंकि पूरे क्वेश्चन सॉल्व नहीं करना है, राइट, पूरे क्वेश्चन आपको कभी भी सॉल्व नहीं करना होता। ओके देन, थैंक यू, हैव अ नाइस डे।